Hello everyone. We are going to move on with lines today and talk about perpendicular lines, but before we do, I'm going to remind you of an old rule of when you're rotating a point about the origin 90 degrees. Remember the point xy goes to negative yx, and that might come in handy when we're taking a look at PR, line segment PR, that has been graphed for you, and we're asked to rotate it 90 degrees with respect to the origin. So I'm going to just calculate those points to start. P prime would be negative 2, 5, and R prime would be negative 6, 3. And when I graph that on the axes, it looks like what you see there, which at times you might think that doesn't even look like it's correct. But remember, if I did connect, let's say P to the origin and P prime to the origin, notice that you do see a 90-degree angle. And the same would be true if I did that with R and R prime. And if it wasn't hand-drawn, those red segments should look exactly the same length as well. And now that we have those graphed, let's see if we can just sort of count the slope of PR and P prime R prime. So looking at the original, PR, I'm noticing that I'm going down 2 over 1. So I would say that the slope of that would be a negative 2. And when I take a look at the P prime R prime, I'm noticing that I'm going up 1 and over 2 in each case, which means my slope here would be a positive 1/2. Now, what do you notice about these two slopes? They look similar, but they're not exactly the same. And if you don't see it just yet, I'm going to remind you that I could write negative 2 as negative 2 over 1. And if you compare that to 1/2, you might say they look pretty much the same except they're flipped upside down and one's negative. Well, we call that relationship negative reciprocals. The reciprocal part means they're flipped upside down, meaning 2 over 1 and 1 over 2. And the negative piece means one of them's negative and one of them's positive. They're opposite signs. Now, something else you might notice is imagine if I extended these lines a little bit. It might be a little bit more obvious. If I extended the blue line and then I eventually extended the black line, can you guess what the relationship is between those two? Now, we already talked about how we came up with those points, but hopefully you're looking at that and saying, you know what, they're perpendicular. And in fact, they are. When you rotate something 90 degrees, I think it lends itself to reason that you end up with perpendicular segments or lines. And now when you think about what the implications of that are, let's take a look at the next page. We already know that when lines are parallel, their slopes are equal. And what we've just sort of discovered is that when lines are perpendicular, their slopes are negative reciprocals. And that's going to come in handy a lot in this lesson and also throughout this unit. So taking a look at the exercises, all I want you to really do is decide if the two lines that you have there are perpendicular, parallel, or neither. Meaning, if you take a look at A, our top line has a slope of 2, and our bottom line has a slope of 1/2. Well, notice that they are reciprocals of each other, because I could write that as 2 over 1, but they are not negative reciprocals, so we're going to call that one neither. Whereas in B, our top line has a slope of negative 3, and maybe you might want to write that as negative 3 over 1, and our bottom line has a slope of 1/3, and those two are flipped upside down, and they are, in fact, negative reciprocals, so we would say that those lines are perpendicular. In C and in D, you have a little bit of work to figure out what those slopes are, so it may not be a bad idea to pause the video and figure out all 4 of those slopes and then decide if they're parallel, perpendicular, or neither. In part C, I found that the slope, moving that 5x over to the other side and dividing by 3, I found a slope of negative 5/3. And in this one here, the second one, moving that 9x over to the other side, making it negative, dividing by negative 15, eventually I end up with 3/5. So again, noticing that these two are reciprocals of each other, and one is positive and one is negative, let's call that perpendicular. And in the last one, hopefully not too much work to figure out that both the slopes are negative 4, which means these are parallel. All right, let's move on to writing the equations of lines. Now, throughout the rest of this lesson, we're going to really just play around with a whole lot of different scenarios that we can come across when we're graphing lines that are either parallel or perpendicular. So starting with the second example, we are given a line that goes through the points 8, -3, and -4, -12, and we're asked to determine the slope that is parallel and then perpendicular. Well, I hope you remember the slope formula, y2 minus y1 over x2 minus x1. And again, doesn't really matter how you start this, -3 minus a -12, 8 minus a -4. When I simplify this all, I end up with 9 over 12, or 3/4. So a slope that would be parallel to the given line would be 3/4, and a slope that would be perpendicular to the given line would be the reciprocal of that, 4/3, but negative. And example 3, or number 3, is pretty much the same. We're going to calculate the slope of line P, which has these points. So again, subtracting my y-coordinates, looks like I have 4 minus 3, and then 8 minus 4, which leaves me with 1/4. And then using line Q, using these points, subtracting my y-coordinates, looks like I have -9 minus a -1, and then 4 minus 2, which means I have -8 over 2, or a -4. And remember, I could write that as -4 over 1. So noticing that this is 1 over 4, this is 4 over 1, -4 over 1, we know that these lines are perpendicular. Now, given the following slopes, what would be the slope of the perpendicular line? Now, it's up to you. It may not be a bad idea to write these as fractions. The perpendicular slope means turn it upside down. I'm going to write it like that, perpendicular m. Turn it upside down and negate it, meaning it would become, in essence, -1. For this one here, though, the perpendicular slope means I'm going to turn it upside down and negate it, but notice that you have a 0 denominator. So the slope here would either be called no slope, or sometimes we call that undefined slope. And I think you know that that means it's a vertical line, which has no slope. And this one right here is a horizontal line, which has a 0 slope. Okay, let's move on. Now lastly, we're going to spend a few minutes writing equations of parallel and perpendicular lines. Again, through this page right here, it may not be a bad idea to pause the video and answer these questions. Check your answers with mine. In part A, the slope of the line y equals 2x minus 8 is clearly 2. Slope of any line parallel to that would also be 2. Write the equation of a line through the point and parallel to that line. Well, I'm going to remind you of the point slope form that you see right there. And I'm also going to remind you of a couple of things that we don't take advantage of very often, is that if we're using a parallel line, remember that we're using a slope of 2, and I'm using the point -3, 6. And remember that a negative minus a negative really just means it's a positive. And you can actually leave your answer just like that. Y minus 6 equals 2 times x plus 3. If you can't bring yourself to do so, then go ahead and clean that up and make that y equals 2x plus 12, but feel free to leave your answer as such. And moving on to D, slope of a perpendicular line, the perpendicular slope should be -1 over 2, or -1/2. And again, writing the equation of this line, y minus y1, x minus x1, I'm going to do exactly what I did in the last problem, where I'm just going to plug in my slope of a -1/2, and using, I'm going to call it a +3 and a 6. And again, I'm going to box that answer in as my final answer. And if you must clean it up, know that you'll have y equals -1/2 x plus 9/2, or 4.5. Now, for the rest of this, I probably will just stop with the point slope form and not clean it up. But again, you may use any method you like. So given AB, write the equation for the line through A and perpendicular to AB. Well, in order to do that, we need to figure out the slope. So again, subtracting my y-coordinates, -7 minus 2, and then subtracting my x's, I end up with a slope of 3, meaning the perpendicular slope will be -1/3. And to write the equation of all the problems on this page, I'm going to use the point slope, which I have written here. And notice that it says through A, so it does make a difference as to which point I'm going to plug in. So A has a y-coordinate of -7, so it's y minus a minus 7, or probably a little more cleaner to write that as y plus 7 equals -1/3 x minus 5. And again, I'm going to stop right there. In part B, we're asked to find the equation of the line through point B, but perpendicular to AB. So using the same slope, and everything is going to be the same here, except the point that I plug in. So if I'm using B, I'm plugging in an x of 8 and a y of 2. And again, I'm going to stop right there. And I'll just point one thing out, that if it really bothers you to leave it like this, I'm going to remind you that when you're graphing an equation that's in this form, it really isn't any extra work. Instead of starting on the y-axis, you're going to start at the point 8, 2, and then go down 1/3. It's just starting at a different point that really is the only difference. So once again, I'm going to suggest you pause the video and finish up the next 2 exercises before you check your answers with mine. And in exercise number 1, we have the equation y plus 4x equals 2. I'm going to get y by itself and find that its slope is a -4. And we'd like to write the equation that passes through 5, 3 and is perpendicular to it. So remember, the perpendicular slope would be +1/4. So using the point slope, I'm going to say y minus 3 equals 1/4 x minus 5. In number 2, we have the point, -5, 2. We want to write the equation that is perpendicular to this line right here. So I think first off, we need to get y by itself. So I'm going to move that x over. And I'm going to find that my slope here looks to be a -5/3 x. And if I want to write the equation of something that is perpendicular, the perpendicular slope I'm going to use is a +3/5. So again, using y minus y1 equals m times x minus x1, putting it into the point -5, 2, I'm plugging in 2 for my y-coordinate, a -5 for my x-coordinate, which we've talked about how minus minus really means plus, and then lastly plugging in a 3/5 for my m. And that's my answer. Again, you are welcome to clean that up if you like, but there really is no need. Now in question 3, probably smartest to start by at least putting a sketch together. Could a line going through the origin that is perpendicular through the origin with a slope of 1/2, so I'm just going to think about what that might look like. Going through the origin, sketch of 1/2 up 1/2, something like that. Let's turn that into a line. It'll look something like that. Could they be perpendicular? Well, remember that this is just a sketch, so I don't know by looking at it, but I know that the red line that is, has a slope of 1/2, and I guess what I have to figure out is, what is the slope of this line? Well, I know that this point here is the point -1/4, and I can just sort of think about what this slope might be to the origin. Well, it looks like I have to go down 4 and over 1, which means that blue line has a slope of -4, and as you can see, these are not negative reciprocals, so they are not perpendicular. And if you didn't graph that, I think you'd have to use the slope formula using 0, 0 as one of your points and 4, -1 as your other, and you're still going to end up with a slope of -4. And our last question of the day is probably the best question of the day. In the diagram below, ABC has vertices 4, 5, 2, 1, 7, 3. As you can see, find the slope of the altitude drawn from A to BC. And as it turns out, we're going to eventually be able to write the equation of this. But remember, an altitude from A to BC means it's perpendicular to BC. So if we want to know the slope, I'm going to label that point D. If we want to know the slope of AD, we know that it has to be perpendicular to BC. So all I really need to do is to figure out what is the slope of BC. And the slope of BC, using these points that are given to me, I'm going to start with 3 minus 1, 7 minus 2, which gives me a slope of 2/5. And that is enough information for me to tell that the slope of AD has to be the negative reciprocal of that, or -5/2. Homework is a little bit shorter than this lesson here, and just like these last few examples. If you have any questions, email me. Good luck.